Join me as I dive into the science behind why the sky is blue and challenge myself to explain it in just 5 minutes. Today, we're going to explore the science behind the color of the sky. It's something we all take for granted, but have you ever stopped to think about why it appears blue to our eyes? Let's start by asking the question: how does light interact with our atmosphere to produce the blue sky we see? It's not as simple as just saying the sky is blue because it's blue. There's so much more to it than that. The truth is, the color of the sky is a complex phenomenon that involves the interaction of multiple factors. Light is refracted or bent as it passes through the atmosphere, and this bending affects the way we perceive color. But that's not all. The atmosphere itself also scatters light in different ways, which further alters the color we see. The real challenge is to understand how all these factors come together to produce the specific shade of blue we see in the sky. It's not just a matter of pointing to a few basic principles and saying, voila. There's a lot of nuance and subtlety involved. And yet, despite the complexity, the end result is something we can all appreciate and enjoy. As we delve deeper into this topic, we'll need to consider the properties of light itself, as well as the composition of the atmosphere. We'll need to explore how light behaves when it encounters different types of molecules and how these interactions affect the color we see. Let's start by examining the concept of sunlight. Sunlight is a form of electromagnetic radiation that travels through space in the form of waves. When it reaches the Earth's atmosphere, it encounters a vast array of molecules, including nitrogen, oxygen, and water vapor. These molecules scatter the light in different ways, depending on their size and shape. To understand this process better, imagine a big party with millions of guests, representing the photons of light. As they enter the party, they're greeted by rows of tables, each one representing a different type of molecule. The photons start dancing and bouncing around, interacting with the molecules in different ways. The smaller molecules, like nitrogen and oxygen, scatter the photons in all directions, while the larger molecules, like water vapor, absorb or reflect them. As a result of these interactions, the light is scattered in different directions, taking on a range of colors. But here's the key insight. The smaller molecules scatter shorter wavelengths of light, like blue and violet, more than longer wavelengths, like red and orange. This is known as Rayleigh scattering, named after the British physicist Lord Rayleigh, who first discovered the phenomenon in the late 19th century. So, why does this matter? Well, it's precisely this scattering of shorter wavelengths that gives the sky its blue color. When we look up at the sky, we're seeing the cumulative effect of millions of photons being scattered in all directions, with the blue and violet wavelengths dominating the scene. Rayleigh scattering is the primary reason for the blue color of the sky, and it's an incredibly important concept to grasp. It's not just about the color of the sky. Either, it has implications for fields like astronomy, climate science, and even optics. To sum it up, the blue color of the sky is a result of the complex interplay between sunlight, scattering, and the atmosphere. By understanding the properties of light and the behavior of molecules, we can gain a deeper appreciation for the world around us. What surprised you most about the science behind the blue sky? Let me know in the comments below, and be sure to check out my other videos on related scientific topics.